Hello and welcome to a new section. In this new section, we are going to study the import address table structure by studying Microsoft Paint PE header. Analysis of Microsoft Paint exe PE header. The Windows NT.h header files contains the structure of the import descriptor. The import descriptor is the data structure that contains information about the import address tables and import lookup tables. Microsoft Paint is found in this location. In this diagram on the left is your Windows NT.h header file, which I've opened in Notepad++, and then I've searched for this structure called import descriptor, and this is the structure, and this is what it looks like. You can see that there are altogether 5 members. The first member is an union consisting of characteristics dword and original first thunk dword. Characteristics dword is now unused. Now it is using only original first thunk. Then the second member is a dword time date stamp, and then you have the forwarder chain dword, name dword, and first thunk keyword. So all these members of this import descriptor is intended to store data relating to where to find the API functions for any particular exe file. So it is used in the following way. Take a look at PE Bear on the right, which I've opened, and I've loaded Microsoft Paint into PE Bear. And in here, I click on the optional header, and then I scroll down, and there will be a field called import directory, and RVA here, the address. So if I right click on this, I will come to this region of the file, which contains all the DLLs that are used by this Microsoft Paint. And all these DLLs here are actually this structure. So let's move on to the next slide, and it will be clearer for you. So now it's the same two files, Windows NT on H on the left and Microsoft Paint on the right, but this time I clicked on the import tab, and it's now clearer. As you can see, this part of the memory is actually for advarp, and all these values in hex here refers to this structure for advarp. And then if you look at this one here, the first 4 bytes is the original first thunk. 1, 2, 3, 4. These 4 bytes here. And the original first thunk is also found here, B02A8, which is this. And then the next 4 bytes will be your timestamp, which is all Fs in this case. And you can see here the timestamp is all Fs. And then the next member is your forwarder chain, which is again all Fs. And as you can see here, it's same, all Fs. And then the next member is your name, which is your friendly name for this advarp DLL. So this is the offset where you will find the friendly name for this DLL. So if you actually went to this location, you will be able to see the name of this DLL in the string section. And then the last one is first thunk. So the last 4 bytes here is referring to 97000. This is the offset to your first function that are exported by this DLL. So advarp exports all these DLLs, and the thunk member of the data structure is pointing to the first function that it is exporting. So this is how you should read it. So the same thing happens for the second part here, in blue. The second part here refers to kernel 32DL. So B0358, you can see here, B0358 over here. And then this B0358 is actually the first member, and then the second member is timestamp, which is this one. Again, we have 4 bytes of Fs, and then the next 4 bytes of F is your forwarder chain here and here, and then the next member is your name, which is here, this 4 bytes here, also here. And this is the, if you went to this offset, you will be able to see the name kernel 32DL. And the last member is your first chunk, which is the last 4 bytes here. And this will be the offset to your first function that is exported by kernel 32DLL. So this is how you should understand this import descriptor. Now, what we mean when we say IAT, import address table, refers to the first chunk. So the first chunk here is a pointer to the first function of the import address table. And then the original first chunk here is known as the lookup table, function lookup table. This is the one. So when the program exe first starts, the IAT is empty, but the original first chunk will have some data that will contain the exported functions, but it doesn't know the address, so it will use these hints here to try to load this address into the first chunk down here. So once all the address is been loaded to the first chunk, our IAT will be fully loaded and contains all the addresses for the functions. So that's how the process of resolving function in the IAT works. All these numbers here are the hints. That means it is something like the ordinal, which we studied before in the previous lesson, where we have all these numbers corresponding to the function names. So these are actually offsets to the address of the function in memory. So we use this, the PE loader will use these hints to try to locate the address of these functions in memory. Once it's loaded, first chunk will contain the complete IAT table with the corresponding addresses for every function. So that's all for this video. In the next video, we are going to do a practical walkthrough on how to look at the import descriptor using a calculator program. So I'll see you in the next video. Thank you for watching.